So we're going to pick up with where we left off last time. We've been talking about how you can make your very own classes in C++. You too can make your own things like strings or vectors that then can be called and used like any other variable type. We've talked about the advantage and sort of the goal of what creating classes is all about, and in particular how by default things in a class will be private. You have to go out of your way to specify that, hey bro, this should really be public. And the idea is that you're trying to basically encapsulate things in this sort of untouchable box. You don't want people cracking it open and breaking it and messing with it. It's sort of like the philosophy of like an iPhone. They're really not meant to be opened up and tampered with, which, you know, has its pros and cons, as you might imagine. So you can define operators. We've been talking about how you can basically make these standard operators do different things than what they normally do. And so you can define operators inside of a class, and you can use those to access functions and variables inside your class. If you define an operator outside of the class, the big reason for doing that would be that it's an operator that might involve two different classes. You can still get access to the member variables, because the thing to remember is that when the member variables are private, you have to have special kinds of functions that have like the special access to actually get to those. And so, you know, if it's something completely within the class, you don't have to do this. But if you're wanting to, say, combine like a vector, which is a different class, with something that your class does, then you would have to use what's called a friend. So you can declare a function or operator as a friend. And that basically gives it access to the things which are private. So what do we have here? So we got our usual headers here. We're going to use the standard namespace and include the IO stream. Let's see. We've got this class light bulb that we've been discussing some last class. So it's got, these things are the private side of things. We've got integer values for the watts, the lumens, and the temperature. On the public side, this is a constructor. So the constructor is basically going to make a new light bulb with default values. Those default values happen to be 60, 500, and 2700. Here we've got a print vals function. This is an accessor function within the class. It doesn't actually return anything, so it is a type void, because it's not actually going to like spit out a value. All it does is it's just going to output and show the user, hey bro, here's the watts, here's the lumens, here's the temperature. And then here's what we're going to do. We're going to use the keyword friend. And so the light bulb is going to be a friend with this operator with a star right here. So we're going to do light bulb star, and what it's going to do is it's going to let us basically multiply light bulb by an integer. Now this is just saying that within the class, things from the light bulb class can use this operator. The definition of the operator is actually down here. So you have the return type. So, you know, just like when we make a function, the first thing you have to do is say what kind of thing will the function spit out? Will it spit out an int? Will it spit out a float? Is it just going to be void because it's not actually going to spit out anything? It's just going to do other stuff. So we're going to have a light bulb return type. We're using the keyword operator because we're going to change what the star operator does. What this operator needs, it's going to take a light bulb object, which we will call bulb, and it will take an int, which we will call increase factor. Inside, just like a function definition, here's what we're going to do. We're going to create a light bulb called ans for answer. And then from the answer light bulb, when we make a new light bulb, it will start at 60. So we're going to take the 60 that it starts with, and we're going to set that equal to the bulb that the operator works on. And that's going to be the watts used times the increase factor. So basically, if we do this operator, you can see here what we're doing. We've got bulb A. We're going to times that by 2. And so that's going to double the watts used. And we did something almost exactly like this, but we did it in a slightly different way. We've basically been doing like the same thing like 3 or 4 different ways. That's kind of what's been happening here. But so we're going to do the watts times the increase factor. We're going to do the same thing here. We're going to do the lumens times the increase factor. The temperature is going to be the same. And then the return type for this operator is it's going to return the light bulb answer. Because again, what it returns is a light bulb. And the light bulb it's returning is light bulb ans. That's the thing it returns right here. So here's what we got in the main program. We are going to create 2 bulbs. We're going to initialize the class light bulb. We're going to create bulb A and bulb B. This would be just like in a normal program if you did like int xy. It's the exact same idea. State the class and then list the names of their variables you're making. Now, because of the constructor function, bulb A and bulb B, when they get made, both of them will have these values, 60, 500, and 2700. Now what we're going to do is we're going to take bulb B and we're going to set it equal to bulb A times 2, which just means that we're going to double 60 and 500. Temperature will stay the same. And then if we take bulb B, and then we do dot, and then we do the print vals function, which is this thing right here from our class. This is a public function. So the main program is allowed to use it because it's public. So you do this print vals function, and it should output 120, 1000, and 2700. And so if we run this, sure enough, there you go. So those are the values that bulb B has. So you're going to include the function operator definition with the designator friend. You can then define the function outside the class and still have access to the member variables. So by putting inside the class, we're like, hey, bro, this operator is a friend to all us light bulbs. So you can give him access to this stuff. So if you take away nothing else from this lecture, just remember that a friend can have a friend can have access to your privates. That's basically what this is. This is the privates, these are the privates. And so the friend has access to the privates. There you go. Let's see. So what do we have here? So the friend will multiply the light bulb times an int. We define the operator function, and it lets us assign the objects of the type light bulb. All right, where is it best to define operators? Inside or outside the class? There's not really a single hard and fast answer. That's kind of up to debate, and in some ways it has to do with preferences, maybe more than anything else. there are some good guidelines or rules of thumb that can suggest when it's appropriate to put your operators inside the class or outside the class. If you're doing something inside the class, that's great for unary operators, because since they only operate on one thing, it doesn't matter. You don't need a friend to have access to the unary operator. If you are going to have an operator that just applies the same action to the same members of a class, you know, if you're going to take something with like a driver and combine it with another driver, two objects of the same class, that's okay to do within the class, because you know that the purpose of this is to combine things from the same class. When it would be outside the class would be if you're going to do two different kinds of classes. So, you know, an int is itself effectively a class. It's a class of variable. It's one of the basic ones that comes with C++. And if you're going to combine an int with a light bulb object from that class, that would be a good time to do it. The other time is if you want to have commutative operators, meaning driver plus car or car plus driver. If you want it to work in either order, you do need to define it outside the class. We saw something similar to this last week, but like here, or last class, I should say, here if I do 2 times bulb B, or I'm sorry, 2 times bulb A, if I do it that way, it is not going to work. It's going to give me an error because you have to do the bulb first, then the integer. Doing the integer first is not going to work. The stream operator is one of the most versatile and widely used operators. If we're going to stream data to and from objects, we've seen this where we do it from the console, C in and C out. Last semester, we talked about file streams where you were reading stuff from a file or printing stuff to a new file. Stream operators are very versatile and they're used all the time. And although it may make sense to us that, yeah, you want to print a string, you want to print a number, those are the same thing, it's the same action. But in the computer's mind, you know, streaming and doing an output with integers is a completely different thing than streaming and outputting text. And so those operators are already designed and overloaded for us by default because, like I said, in the computer's mind, we would basically need like different symbols if it was a different kind of variable. So what we could do is maybe we want to declare an object light bulb and be able to see in or see out information from it. So inputs go to the right, outputs go to the left. We're not able to use the stream operator inside the class because it comes from the IOStream library. So when we do this, we're going to have to declare the stream operator outside of the class and make light bulb a friend. So the stream operator comes from IOStream. That's the library where it lives. So since it is something outside of the class, if our goal is to stream information from a light bulb, we need to do that as a friend to the class. So let's check this out, shall we? So what do we got? So we're going to include IOStream. We're going to do the standard namespace here. Here's the private. Here's the privates of the light bulb class. We got our constructor function like before. Here, what we're doing, we're defining a friend, and we're doing the OStream operator. And so the O stream operator is this symbol where the arrows point to the left. The name of that is the O stream. O stands for output. So this is like with a C out statement. This is where we would display something on the screen. And then what you do with this operator is you start with the O stream, and we're doing a pass by reference here because inside IO stream is an O stream like box. And so we're not going to create something new. We're just going to refer to that box basically. And then here we're going to make a constant, and we're going to pass by reference a light bulb object. And we're just going to set it as a constant here. So then the class will have access to this operator because it is a friend to the O stream operator. Here's the operator definition here. So we're going to do the O stream. That is the output type. It's going to be a stream of outputs printed on the screen. We're using the operator keyword, and we're telling it which operator to use, which is like the double less thans, which looks like an arrow pointing left. We're going to have an output stream that we'll call S. We're going to have a constant light bulb that we will call B. So then what we're going to do is S, the output, we're going to just do this as a stream the way we have like previously. We're going to say B of watts used, that'll print the watts. Do a space, do B of the lumens, then do a space, then do B of the temperature. So then by doing this, what this lets us do, we can create a light bulb that's going to have these values as defaults. And then basically we can just see out bulb. You know, before when we had ints, like, I'll give you something to kind of compare this to that we've done previously. Like you could declare an int x. Whoop, let's try that again. You could declare an int x and initialize it to 1, and you can see out x and then end the line. So instead of just outputting 1 as text, what this cout statement does is it will just output whatever value the box X has inside of it. And we don't want the operator to ever change. All we want it to do is to display the values in light bulb. We don't want it to change them in any way. That is why this is defined as a constant, because it's basically going to fix these values, because this operator is not made to change things. It's only made to display things. So we've defined the O stream operator. So now we can do this just like we would an integer, x. And so if we output this, or if we run this rather, so like when we stream x, it gives us the value 1. When we stream the bulb, it prints us the watts, a space, the lumens, a space, and then the temperature. So we can now stream light bulb objects. And we could already stream things like integers. Now we can stream something like a bulb. So we can now stream a bulb object in our main program exactly the same way we have streamed integers and strings. Incidentally, if I am inputting something into a stream, that's what the I stream is. So you could, if you wanted to define the arrow that goes the other way, that would be called an I stream. That would be a little more complex, but that's basically where you would read something in from the keyboard as opposed to print something out on the monitor. So that is the end of the lecture part of things. let's look at what the next assignment is. So this is going to be drawing from, it's going to be drawing from the week 8 and 9 stuff, as well as the week 10 and 11 stuff. So here's what we got. So the first task is you're going to create 2 namespaces. I want you to call the namespaces Blackjack and Schoolyard. Inside each namespace, you're going to have a function called Hit Me. If you are not familiar with the game Blackjack, the way you request another card from the dealer is you say, hit me. So what we're going to do is if you call the hit me function from Blackjack, all I want the function to do is just to see out some text and say you have a new card. In the Schoolyard namespace, I want you to have another function that also is called hit me. They are supposed to have the same name. And I want the function for the Schoolyard hit me function to output the text, ow, that hurt. So depending on the context, hit me could either mean that you've received a card or that someone like actually hit you and now you're saying, ow, that hurt. In the main program, I want you to then call both of these functions so that we can see their outputs in all their glory. In the notes, there is an example I did where I believe the name of the function was greeting. I had a namespace called English. I had a namespace called Spanish. This task should look very, very similar to the English, Spanish namespace example with the greetings. Next, for the last 3 parts, they're all going to be based on making a class. And we're going to make a class for a blackjack game, and we're going to call this class player. The class should have member variables for these 4 things. So the class, kind of like my light bulb example, it'll have variables defined within it. The variables should be as follows: the number of cards that are in their hand, the point total of those cards, the total cash that the player has, and then the current bet that the player has made for that hand. The point total should be public. All the other variables should be private. So all that part 2 consists of is making the class. And that's sort of like a stepping stone to do parts 3 and 4. These would really be like kind of like all one program together, basically. I guess you could do it as 2 programs where you'd have 2 and 3 and then 2 and 4. You could do it that way. But for part 3, you're going to do stuff with a constructor and a member function. So in the player class, you're going to have a constructor. You're going to initialize the number of cards to 0, the points to 0, total cash to 1,000, current bet to 50. So fun fact, we've seen lots and lots of examples of this, but this right here is a prime example of a constructor function. And the first task in part 3 is basically asking you to do something almost exactly like what I have highlighted here. The names will be a little different, the numbers will be a little different, but this is basically what we're going for in part 3. You're also going to create a Boolean member function. I think if you look under the vending machine examples, you will find a bool function that you can use to serve as like an example or a template. And so basically it's going to be a Boolean function, and it's going to be based on whether it is true or false, did the player win? So if the player wins, what the function should do is add the bet to the total money. So for instance, if they have $1,000 and they bet $50, you would add the $50 to their total cash. If it is false, you're going to subtract the bet or actually we should probably call it the pot rather than the bet, because technically you win the pot, not what you bet. But anyway, that's not a super big deal. But essentially, you're going to create a member function where it will add the value of the pot to the amount of money that the player has, because they won, which means they get the pot. So let's actually call this the pot. So this is the current pot of that hand. We'll do that. And then let's see here. Add the current pot to the total money. If false, subtract the current pot from the total money. And then let's see. So all you're doing is you want to make a function. If it's true that they won, add the pot to the total, and if it's false, subtract. The last thing you have to do is overload two different operators. You're going to do one binary operator, and you're going to do one unary operator. And again, if you use the notes as kind of a template, that should give you an idea of what this should look like. I want you to overload the operator star or asterisk and multiply the current bet by a factor that is passed to the function. The idea is that, and actually maybe we should have both a bet and a pot. Maybe we'll do that. Anyway, so in blackjack, there's something called doubling down, where essentially, I forget the circumstances when you're allowed to do it, but basically you get to double your bet, or I think you get to double your bet, but then you only get to hit once as opposed to hitting multiple times. So that's not that matters. So let's see here. So let's do the current pot of the hand, and then let's also do that. We'll also do the current bet of the player. So we'll have both a bet and a pot here. So this will add the current pot. Let's see, we'll have the current pot be $100. The current bet will be $50. So if it's true, add the pot to the total money. If it's false, subtract the pot from the total money. And then we're going to overload the operator to multiply the current bet by what's passed to the function. And you're going to double the bet. And then we'll overload the operator plus plus. And so what that'll do is we will use plus plus. It'll essentially be like a hit me function where it will add a card. And so the variable that will keep track of how many cards the player has, it will add one to the player's hand. And then maybe we'll add this here. In the main program, give the player a starting hand of 2 cards. So you'll basically have to do that function twice, because in a game of blackjack, a player starts with 2 cards. So that is the rundown on what the project is asking you to do. So hopefully it shouldn't be too bad. Most of this stuff, there are similar kinds of things in the examples, and some of the examples are maybe a little bit more complicated than these, but I feel those should be doable tasks. So